already assigned you guys. If you actually go to our class webpage, you should be able to see what I've got written down for homework for week 2. And you can look at it now. I'll show it to you guys when we get started here in just a couple of minutes. Um, we'll get it. I'll walk you through it and we'll check some stuff out. I've got some interesting things for you. So I am shipping my kids off to my in-laws' house for the weekend. So that's going to be fantastic.
Party at your water park.
Yeah, it means that I get to watch all of the anime and all of the cool movies that I want to watch. That's what I get to do. So
That's a
Are
good
you
weekend.
using the American Postal Service?
American Postal Service.
Yeah,
No,
ship your
because they weighed too much. It was gonna be too costly.
Too expensive.
Too costly. I calculated it, and to ship them, I could buy the equivalent of a Nintendo Switch or something like that. So I think I'll hold off on shipping them.
Are you saying you'd rather buy a Nintendo Switch?
Yeah, that is actually what I'm saying. I hear that those are like sold out like everywhere. And then did you hear about the controversy of like the teenager, the dude that like is your guys' age, that came up with like a coding way to basically like guarantee that he'll get like jumped to the top of the line for when they come available. And he like
What?
gave it to all of his friends. So like, cause it apparently, all right. So literally the story is something like this dude was like, I need a Nintendo Switch. He got one. And then his friends were like, I need one, but they're all sold out. And so he was like, all right, just a second. So he came up with some like quick script that he put together to basically bump people to the front of the line on the virtual checkouts. And then like, so that all of his friends were just like literally buying up all the Switches and stuff like that. And so but then it became like this big deal because then all the companies are basically like kind of upset because he's manipulating their systems, but he's not doing it to gain profit. And so now people are just like, they're using his, like he released it. He put it up on GitHub and he was like, have fun. And so now everybody's like using it for all kinds of stuff. And it's a really interesting story. But I think the dude's only like 16. Like he's just literally just like, yeah, I just did this because my friends were like, every time I try to buy one online, they're always sold out. So I'm just, and so he's like, okay, well, I'll fix it. And it was, so, oh my gosh, you guys, it's going to be interesting. Anybody got any cool plans for this weekend? Just going to be hanging out, doing stuff. I think I'm going to try to watch, I think I'm going to try to get into, what is it, Studio Ghibli. I think I'm gonna try to watch some Howl's Moving Castle. I love that one.
I'm going to go throw some. I have to spell this out because there is a little kid near me, but I am going to go cat FISH.
Oh, cool!
Really excited.
Yeah, that's pretty awesome. Is that? Oh, we got somebody else saying that they're going camping. That's pretty sweet. We got lots of outdoorsy things. It's
like the original social distancing.
Yeah, right. I almost got a mask. I ordered a mask the other day. I got one that's Spider-Man mask that's coming, and then I've got another one that has got this alien spaceship, and it's literally beaming up Bigfoot, and it just says "Get in, loser." Like it's kind of funny. Like, get in, loser. And like,
I'm into it.
But I did see one that had a Bigfoot on it, and then it said like Bigfoot, like social distancing champ, since forever or something like that. Like it was kind of cool. So, okay, all right. So what I'm gonna do is we'll go ahead and get started. And so today, let me go ahead and do a screen share here. So I'll pull over to the week 2 homework. Well, I guess first what I should say though is how did everybody feel about the homework for last week? Did anybody have like major problems or anything like that?
It was pretty simple.
Pretty simple?
I did it in like 30 minutes last night.
Sweet. So what you're telling me is you want me to give you like 5 times as much homework? Is that what you're...
That's what I heard.
No. I think you're good. Well, I didn't want to overload you because I know you guys got other classes and stuff like that. But what did you find out? So like, what did you determine? What did you get from your graph?
The green light doesn't work.
Green light does
Red
not
light?
work.
The red light's like the best light.
Green
I
light.
Blue was the best for me.
Yeah,
I
especially.
I found red.
I
don't
was
know.
surprised that like yellow or red wasn't the best because you would think that the closer to like the actual sun, it would grow the best.
Oh, that's a good comment. Let me pull up this real quick. Let me. So as far as like results, all right. So we found out that green, no good. And so we also then found out that you guys are saying that green, no, green's bad. And then what were the two that worked the best for you guys?
Blue was the best
I think it was
of all
blue
of them.
and red, maybe.
Blue and red. Okay. So blue and red are going to be those ones that are going to be that worked the best. Okay. And so then we have to think about too, like sunlight. All right. Like, what does it consist of? All right. You know, this is actually pretty interesting stuff. Now, when you guys think about it, have you guys ever heard of like the colors of the rainbow? Have you guys ever heard of like that acronym to kind of like lay out the colors of the rainbow before? Have you ever heard of this? We usually say Roy and then G Biv. This is really kind of like what they're talking about. And so what this translates into is red, orange, yellow. Remember, I screwed up and I put yellow in there, but you guys, I don't think you had yellow, or maybe it was orange. One of those was missing. And then we had green, and indigo, if I can spell right today, and then violet. So this is basically when you see a rainbow, this should be the way that the colors show up. So if you want to correctly make a rainbow, this is the color order that you should put your colors into. Now what's kind of cool about this stuff is that this also coordinates to energy levels. All right, so how many of you guys have ever had a red laser pointer? Did you ever have one of those before? They're like everywhere, right? You can use them. I play with my cat with them all the time and stuff like that. Which one do you think is more powerful? A red laser pointer or a green laser pointer? What do you think?
Probably red.
Probably red? You guys ever had a green laser pointer before? You ever seen any of those? Let me see if I can't pull up a quick vid for you guys on this one. We'll see. Okay, let me pull this up here. And let me come back. Let me do a new share. We're kind of flying by the seat of our pants today, people. This is not what I originally had planned, but we're going to go with it for a little bit here. So let me pull up. Let me see. All right, there we go. All right, so let's check this out. This is the 3-balloon laser test. Will it give us the information we want? I don't know. We'll have to check it out. Oh, this is kind of interesting.
Andrew, did you want us to hear the sound of the video?
There is no sound.
Okay, good.
But let me, actually, if you guys didn't hear that popping sound, then you need to hear that popping sound. For some reason, usually on mine, it's like literally like already clicked. And so I forget every time. So, all right, let's go back to that. All right, so this kind of also kind of plays into this whole idea of what we're talking about before. This is actually a better video than what I thought it was going to be. So as a classical sense, right, when we consider just these energy levels, and let me come back here real quick. When we come back here to this, let's see here. Yes, let me pull the chat over to the side so I can see what's up. Red, orange, green, blue, indigo, violet. Yes. Did I miss one? Red, orange, what did I mess up? Red, orange, yellow, green, violet. Oh, yeah, thank you. Anytime that I go from, when it's just me as a presenter mode, where I can see everybody, if I go to screen share, it totally takes away my chat and it like shoves it into another window and like puts it randomly, I feel like, anywhere on my screen. So I've got it all set up now so I can see this here. So thank you for calling that out, Brad. Yeah, and thank you, Jake, everybody else. When we think about these energy levels, red is actually going to be at the low side of the energy levels. So the photons that make up the red energy level is going to be lower than those that are orange, yellow, green, blue, indigo, violet, and then basically we start getting into stuff like ultraviolet and stuff like that up here. So as we go this direction, we are basically increasing energy when it comes to the different wavelengths of light that we're talking about. So like traditionally, you want to think about red laser pointers are kind of be on the low end of the spectrum. Now, if you really juiced up a red laser pointer so that you know, it's not just about the color, it's also about how much power you're delivering over an amount of time. But typically thinking, when we think about traditional laser pointers, a red is going to be a little bit weaker than a green laser pointer. And then a blue laser pointer is going to be a little bit more powerful than a green laser pointer. I used a green laser pointer in class one time and my students all literally were like, I can't see. And so I literally had to send it back. I was like, I can't use this in class because it's too powerful. And so one of the things that we can do with these laser pointers is you can use them. One of this is these balloon popping tests, which is what I kind of just showed you over here. Now, you have to be careful when I say this. Laser pointers, especially when you get into the higher powered laser pointers, have the ability to basically denature the proteins that make up the receptors in our eyes. And it doesn't take very much, just a quick second, just second of exposure, especially when you get into the higher laser pointers, that will literally damage your eye. You can't get it back. It's irreparably damaged. And so when you work with lasers and you're messing with laser pointers and stuff like that, it is very important that you follow the proper safety protocols for that. And a lot of times that requires wearing special glasses that are resistant to whatever wavelength of light you're using. And so I do not recommend that you try this on your own at home, but I will show you some of these effects, like when we're talking about this video right here, so that we can actually, it relates back to the plants. So let's take a look at this again. This is from the Hansen Research Group, Florida State University. First, what we want to look at is what color laser are they using? So they're using a green laser pointer, right? So they've got a green laser pointer and they've got a green balloon, a black balloon, and a white balloon, all right? So which one of these pops? Let's go through and watch it again here. They're leaving it on there for a second.
Wow.
Is that it? Is that the end of the test? So then, what do you think is happening? I want you to think about it for just a second, all right?
The black balloon looks like it absorbed all the energy, while the others were reflecting some of it.
Okay. So what you're saying is that when the laser was pointed at the green balloon, it didn't absorb as much. What do you think made it pop, though? What do you think? Would you go outside today? Like if it was like super, super hot outside today, what color clothing would you wear?
White, not black, because the heat made it pop.
Ah, okay, right? And that's exactly what that's what you're getting at, right? This whole concept of like absorbing, right? So typically when we think about colors, we think about black as being capable of absorbing the most energy, the most photons from the widest variety of wavelengths, right? White we think of as reflecting the most. And so why doesn't the green pop then? So if the black is capable of absorbing
the green just completely reflects it all because it's green. That's what we see.
Okay. So then what is the green specifically reflecting?
The green light.
Okay. So then which one do you think is going to be the one that, do you think that they'll have equal reflection between the white and the green? What do we think? What do we think? This is actually a really cool experiment.
More than likely, because the white has green too.
So the white should reflect it. And then because we're using a green laser pointer, it also is reflecting the green. So I would imagine that these are fairly similar in their ability to reflect the actual green laser pointer. Now, if we had a different colored laser pointer, like a blue laser pointer, we might actually be able to pop the green balloon as well. But it would be interesting to see what would happen for a blue laser pointer on a white balloon. And so this comes back to exactly what you guys were talking about with your findings for this last experiment for this last week, which is that you found that the red and the blue worked the best, and that green just sucked. So
I do have a question. I do have a question with the energy levels. I believe one of my science teachers had said something about like fire being like that as well, the colors.
Oh, okay.
And now that I also think about it, I think I've also heard that a red sun is lower energy level than a yellow one.
So when we usually think about fire, so first of all, when we talk about fire, what you're actually feeling coming off of the fire is that infrared heat, right? Which is actually a photon. So you're seeing photons that are associated with the flame, but then you're actually feeling photons that are associated with the heat. So the fire itself is giving off photons of varying energies. And so if we had a look at our chart down here, this is what we refer to as the visible light spectrum. And so if this is on the low side of energy and this is on the high side of energy, those photons that we feel radiating from fire would actually be down here. They'd actually be low energy. And then a lot of the photons that are coming off of the flames correspond to then also the amount of photons that they're radiating, but then also what kind of chemical elements make them up. So, all right, we're going to get into just a little bit of a conversation here. To really kind of understand a little bit about what this is about, we kind of have to go into, let me show you here. Let me pull up this video for you here. Let's go to Hill 3D animation on photosynthesis. Pull this up here. So let me come up here and let me show you. The fire is a little bit different from what we're talking about with plants, because in fire, you're breaking a lot of bonds, and that contributes to the energy and then those release of those electrons that make those up. And so we end up with basically excited electrons that then when they fall back through their energy levels, they kick out photons of various energy. But let me show you here. This is a good explanation for this. And I believe you should be able to hear it.
In order for plants to grow, they need...
Did you hear that? Okay, cool. Let's watch just the first part. We're not going to watch all the way through it, but let's watch a little bit of this.
Inputs of carbon dioxide, water, and energy. The chemical process by which plants use these resources to manufacture glucose, the building blocks of plants, is called photosynthesis. In the process, oxygen gas is produced as a byproduct. The energy for photosynthesis originates in the sun and arrives at the Earth as sunlight. This light has both a wave and a particle nature. The particles, or photons, are the smallest units of light. Photons oscillate along a path, which is measured as wavelengths. The light emitted from the sun contains photons in a wide spectrum of wavelengths, called the electromagnetic spectrum.
Now, this is a little bit backwards from what I've drawn, what we've written out on the Word document. So what they're doing is they're actually showing infrared and radio waves on the low side of stuff on this side versus high energy on this side. And then look though, here's the red, orange, yellow, green, blue, indigo, like right here, right? So this is the colors of the rainbow. And so radio waves, this is what's kind of trippy about this stuff, guys, is that radio waves are photons. Infrared heat is photons. Wi-Fi is photons. Like digital signals from antennas, they're photons. X-rays are photons. UV light are photons. Everything is freaking photons. Like all of that stuff is photons. It's all packets of energy. So when you pull out your phone and you're connected to the Wi-Fi and everything like that, it's emitting photons of a particular energy that are then going back and forth and being absorbed, and then that is then transmitted into some kind of, 1-0 program, all that stuff. But photons are freaking everywhere. And if we could see all of the photons that are around us, I think that you would be inundated. You wouldn't be able to do anything because there would just be so much junk that was available there. You guys ever had an X-ray before? You ever go to the dentist and get X-rays, or you ever go to the doctor and get X-rays? Do you see the X-rays when they give it to you? Do you see them? I mean, you see the outcome, right? You see, yes, I have a broken bone, or no, I don't. But when they actually do it, right? What do they say? They say, okay, don't breathe, hold real still. And then they go, eh, and then that's it, right? You're in a dark room most of the time. When that happens, you don't see anything. And that's because you don't have receptors for those photons. But they just blasted you with high energy photons.
Aren't gamma rays like deadly?
Oh yes, you do not turn into the Hulk, you die. So the whole idea of getting blasted with gamma rays, and the reason why they kill you, is because our DNA is basically made out of chemical bonds, right, that are held together by electrons. Well, if you get blasted by these gamma rays, they eject those electrons. So basically your DNA gets shredded up like newspaper. And if you don't have any, if you don't have a book to tell your cells how to run, your cells, they dead. So
now the sun emits that, right? So does our atmosphere like keep that from?
Yes, and I don't know how much gamma ray actually comes off of the sun. Sometimes there are interstellar events that produce massive bursts of gamma rays. This is actually one of the theories for why the dinosaurs went extinct, is because we had a big gamma ray burst, and that the Earth's protective layer, like what you're talking about with the atmosphere and its electromagnetic sphere, was not enough to protect it. God, you guys are getting me so off subject today. You guys are crazy, because another really cool thing that you guys probably don't know about is the fact that because we've got so many radio stations, TV transmitters, all of this electronic communication that we're doing, we've actually created our own artificial electromagnetic sphere around the planet. So historically, when the sun activity either dies down or goes up, we have to worry a lot about the whole solar winds and everything like that. We've actually found that because we transmit so much information and we communicate so much, we've actually created an artificial electromagnetic sphere around the Earth as well, in addition to what's already there. And so we're starting to try to understand, for the first time in the Earth's history, has this really happened? So this is not normal to its normal cycles. And so how does that affect the climate coming up? We don't know. We're just trying to figure it out. But radio waves and our abilities to basically communicate around the planet now have kind of had consequences. So let's watch just a little bit more of this.
Photosynthetic organisms use only a small portion of the electromagnetic spectrum, called visible light. Photosynthetic organisms contain pigments that facilitate the capture of wavelengths of light in the visible light range. The color of the pigment comes from the wavelengths of light reflected. Plants appear green because they reflect yellow and green wavelengths of light. Red and blue wavelengths of light are absorbed by these pigments and provide the energy that is used for photosynthesis. Within eukaryotic photosynthetic organisms, also known as photoautotrophs, the chemical reactions of photosynthesis occur within plant cells in specialized structures known as chloroplasts. Photosynthesis consists of two sets of reactions, the light-dependent
Almost done
reactions and the Calvin cycle.
We're not going to go through all
Within the
that.
chloroplast are small disc-like structures called thylakoids, which are surrounded by a fluid-filled space called the stroma.
Come on.
The reactions that synthesize glucose, the Calvin cycle, occur in the stroma. The light-dependent reactions occur in the thylakoid. It is here that conversion of light energy to chemical energy is initiated. In most photosynthetic organisms, thylakoids contain pairs of photosystems, called photosystem 1 and photosystem 2, that work in
PS1,
tandem
PS2.
to produce the energy that will later be used in the stroma to manufacture sugars.
You guys weren't even alive when those came out.
The photosystems of the thylakoid consist of a network of accessory pigment molecules and chlorophyll, the molecules that absorb the photons of light.
That's it. That's all I wanted to get to on that one, is that chlorophyll is the molecule that's associated with absorbing that light. So when you guys were blasting your plants, right, the plants were able to produce chlorophyll, and that chlorophyll is the actual molecule that's going to be absorbing that red and that blue wavelength of light. And so we don't need all the other wavelengths. All you need is red and blue. So what can we do with that? What can we do with that? So if we come back over here, what did we say? What was some kind of application, or what can we do with that? Can we select wavelengths of color? How can we do that? What are some things that we can actually use to select wavelengths of color?
Filters.
Okay, so we can use a filter. That's true. Would that be very energy efficient? If we used a filter, we would still have to put out the same amount of energy, but what we'd be doing is putting a filter, right? So that only those certain wavelengths would get through there. There's another way that we can do it that's way more energy efficient. What do you guys think? What do we got? They're ridiculously cheap now. They're pretty much embedded in absolutely almost anything.
LED.
Yeah. We have LEDs. Those stand for light emitting diodes. And we can select their wavelengths. And they're pretty sweet. So let me show you. You guys actually probably have LEDs in your house. Like that bulb that's behind me right now, that's up in the ceiling fan. Those are all LEDs. Oh yeah, look at that. It's like you got like your personal shrine in your room or something like that. You know, like that's
My light is
oh,
blue right
cool.
now.
Yeah, like and you guys have probably seen those smart bulbs where you can basically kind of like, I think you
That's
get them
what
at
this
Walmart.
is.
Yeah, and you can change the light, and you can even have like party mode and stuff like that. And it's just like, you know, and so the LED stuff. Why do we have LEDs in our house? Why do we have LEDs?
Because they're cute.
Okay, I'll give you that.
They're efficient. They don't take much energy.
That's true. All of the above is true, right? So
And they're small.
fun. Yeah, and then do they heat up? Do they heat up as much?
Not as much, but they still can.
Yeah. And so if it was a traditional bulb, like a filament style bulb, if it'd been on for an hour or so, you wouldn't want to go up and just grab it because you'd end up burning your hand. That's how hot those are. So the LEDs are energy efficient, they're cooler, and basically we can select the wavelengths. So this is big time application for farming. And let me show you let me pull this in over here. So like a lot of this stuff, you can end up with growing plants indoors using LED systems. And so this is actually kind of like a big kind of like cool thing. And what was really kind of shady about all this stuff is that if you were to research this about 5 years ago, 6 years ago, all that would come up would just be hits for growing marijuana inside. That's literally all that would come up, because a lot of times growing with LEDs was a way to circumvent a lot of the detection mechanisms that people put into place. So if you're growing pot in your house, the cops are going to be driving around the neighborhood with a heat gun, and they're going to be like, why is that person's basement like blazing hot? You know, why is that? You know, they're going to be looking for signs like high energy use. This person's power bill is off the charts. This person has got rooms that are ridiculously hot. And then you coordinate that with shady activity, then potentially you could probably get a warrant for it, stuff like that. So a lot of this stuff with the LEDs, this was all kind of like a pioneered underground. There was definitely like this like underground, you know, illegal activity that was associated with a lot of this stuff. But nowadays, people use them for all kinds of sorts of things, and people grow all kinds of vegetables and everything like that inside. In fact, I grew all my pepper plants in my garage over the wintertime using LEDs. Now my garage looked like it was crazy because it was super, super bright and it lit up everything, but it was enough that my pepper plants survived over the summertime. So I actually had a couple of pepper plants that I was able to winter through and grow up this year. So LEDs are the wave of the future, is what we're talking about, especially when we're talking about growing plants. Do you think that this might be important for growing plants in space? Maybe that would be acceptable, right? Low energy, low heat, and then basically we can select for that. What would be some of the advantages of growing plants indoors? What do you think?
You can control the environment.
No bugs.
Okay. What was that, Bree?
No bugs.
Brielle? No bugs? So if we don't have bugs, do we have to spray it with pesticides?
Nope.
Nope. Don't have to use nearly as much pesticides. And then also, since we can control the environment, that means that they don't get nearly as hot, which means that we can actually limit the amount of water that we use on them too. So this whole concept of figuring out what wavelengths of plants use and then getting those into efficient systems so that we can grow up food for the future is super important. You know, one of the things that they did for my environmental life science classes, we looked at this, all that it would take 3 soccer fields. All right. So you'd have to build a building that was 3 soccer fields deep, which means 1 soccer field. And then imagine level 1, level 2, and level 3. Okay. 3 soccer fields of indoor growth would be enough to supply a city the size of Lawrence, Kansas, which is a pretty big city. Okay. With 500 grams of fresh produce for every single person every day for an entire year. And so if you think about Lawrence, Kansas, that's over 100,000 people, and you think about the town of Chanute, that's about 10,000 people, if you had an indoor facility that was the size of a soccer field, you potentially could grow enough vegetables, right? Let's get some 9-story soccer fields in, right? That's what I'm talking about. And so literally, you know, and you're not at the mercy of the weather per se. Now I hear right now that Chanute's actually in like a drought warning, right? Is that what I'm hearing? That Chanute's got like a drought warning going on right now? We got some rain recently, but you know, now we have to start thinking about, okay, well, where are we going to get our water from? You know, how are we going to do that? And we have some other systems for that. But how do you think growing food locally, I mean, like, would it be a good thing? Would it be a bad thing? Like, what do you think? What are some pros or cons for?
Well, if you grow it locally, it doesn't have the chance of spoiling.
Okay, so
You may not have to use as much preservatives.
decrease spoilage. All right. Less treatment. What else?
Minimize
Could be
your
cheaper.
carbon footprint because you don't have to factor in transportation costs.
So if you guys do go to the grocery store and you go to the section where you're looking for your vegetables and stuff like that, a lot of times now they'll actually tell you where they come from, right? You guys seen that? They have the little stickers that say this was within 50 miles of this store, or these jalapenos are from Mexico. For those jalapenos to get here all the way from Mexico, they had to be harvested, they had to be washed, they had to be transported either by train, tractor trailer, or plane. You know, likely they're coming across on tractor trailers, which then causes carbon. You know, we have to supply the gas and the trucker and everything like that. And so if you grow things locally, potentially what you're doing is you're cutting down on that carbon footprint. You know, they had these things back in the day. We call them victory gardens to kind of help with the war effort that's going on and all kinds of stuff like that. And do people, I want you to think about this, all right? Do people really utilize the front lawn as much as they probably should? Do people like having like a nice green front lawn that's like trimmed down and everything like that? Because it looks nice, right? But is it really functional? For those people that have big front lawns, do you really ever see people outside playing on those front lawns like every day? Right?
You make a good point. I guess I'll go out and start farming.
Well, there you go, right? On some level, that's kind of what I'm hinting at. And so if you've got the land and the resources to do something like that, potentially then growing your own food and vegetables, right? Those are those things that are then going to be able to help you out. And actually, have I ever showed you guys the TED Talk on urban farming with the LA Green Grounds and the guy taking back his city? Okay. I don't think that we have enough time to watch that for today, but I'll put it on the list. Let me make a note of it here. It's a TED Talk, and maybe I can just attach it for you guys. Now, there is some language. There's a little bit of language in the video. One of the shirts that the guys got on literally says "un-F the planet." I thought that was kind of interesting. I mean, it's a very like in your face, like we're going to be as real as we can. We're going to talk real. We're going to do stuff real, like that type of thing. But it's a TED Talk. I think it's called guerrilla, like guerrilla warfare. You know what I mean? Like that whole concept of guerrilla warfare. I think it's called like guerrilla gardening. Gardening. It's with LA Green Grounds. And basically, the guy, there's that little space in front of his house where it's from the sidewalk to the curb, and he has to maintain it, but the city owns it. And so what he said was, if I got to maintain it, I'm just going to grow whatever I want there. So he turned that area into a garden. And then the city came back and fined him for it and said, you can't do that. You got to tear it up. And then he didn't want to pay for the fine. He thought it was a social justice issue. So they actually issued an arrest warrant for the guy. And then, so then he got petitions and then kind of like brought awareness to it and like all this stuff and everything like that. And so, which then kind of goes back to what I wanted to explore today with you guys on this. And so let me come here. So this is, I want to check out places where we could potentially do a community garden in Chanute, Kansas. And so I've given you a couple of concepts here. So this one right here, if you click on this, it's going to take you to a Strava heat map. Now, if you guys have never seen Strava before, Strava's pretty cool. What it does is that it aggregates athletic data. And when I say athletic data, what I'm talking about is data that people give that basically records where they exercise and how they exercise. So this is the city of Chanute. Okay, I don't want to go down super far. You can sign up if you want. It doesn't cost anything, but it basically gives you information about the town. All right, so this is Santa Fe Lake. Okay, but look at this. If I click on just foot traffic, these are the parts of Chanute that light up. So these are the most common routes that people take when they exercise and get around in Chanute. What do you think this is? Do you guys know what this is? That's the Katy Park Trail. So that's the Katy Park Trail. Here's the Katy Park the actual community gardens right now are over in this section. But the problem with that is that the last couple of times that it's flooded, it's completely destroyed the community gardens. Like if your garden gets flooded by a river, because everybody dumps everything into that river, it's not safe to eat from it for at least 30 days. And so really that kind of kills any kind of growing season that you have over the summertime. And so here is Santa Fe Lake. This is that bridge, that little thing that splits between the South Santa Fe and North Santa Fe. And you can kind of see, what do you think that is out there? You guys know what this is out here? That's the track at the high school. That's the track at the high school. So people walk the track for exercise and it records on their heat signature where they are. And so why would I give you this? Because do you think having a community garden, we probably need to put it in an area where people are going to be capable of going or already have a habit of going? You know, like, would we really want to try to put a community garden out here? Nobody ever goes out there and uses it, right? And so what do you think are some important things, right? So one of them has to be, it has to be kind of like public land. And then it has to be in an area where people will actually go. And then if it was close to a water source, wink, 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 right? Lego style, okay? Wink, 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 wink. Then literally like that might also be helpful as well. So I've given you the link for the Strava heat maps so you can kind of explore. And you can use these for any of your own communities. Some of this stuff is crazy, guys. Okay, all right. So Strava kind of got in trouble about a year ago because you kind of had to opt out of the data collection, which meant that a lot of people were just donating data and they didn't realize they were doing it. And so Strava got in trouble because a lot of people in the military would go out for a run, but when they went out for a run, they would literally just run the perimeter of their base. And then that was being recorded to the heat maps that anybody could look up. So then people were like, oh, is that a military base here? And is that the dimensions of the military base? Because we can basically, yeah, it was a big like boing, like, and so then they've fixed their data collection. But if you Google this stuff, this is where the crazy stuff is. There's certain heat maps that show up like in the ocean where people are like, if I look on Google Maps, there's nothing there. Like, why is there heat maps there? And there's crazy heat maps that were showing up down in Antarctica where they're like, what is this? Like weird, like geometric patterns of like areas that people would have to like transverse and stuff like that. And so people were like, oh, they were just totally like, all of a sudden this was all the rage. People were like looking at the Strava heat maps. And I guarantee you that I bet if you Google that stuff, there's probably web pages that still have that information dedicated to it. But I looked it up. I thought it was cool. I was like, what is all this stuff doing down here in Antarctica? And like, where's this stuff in the ocean? It was kind of like a mystery type of thing. But these heat maps are really good for city planning, you know, and then like, check it out. That's the foot traffic. Here's the biking traffic. Notice how they don't overlap a lot. So you can see people that bike versus people that walk. And then I don't know what the snow is. Swimming, no swimming. You either walk or you bike. And then that kind of shows you some of the routes that people take. You know, I think it's interesting that a lot of them just end right there. Like what's down there? I think the city dump is out here or something like that. So, you know, this is kind of neat. And so I've given you this heat map so you can check that out. And then obviously just a link to Google Maps. You know, why would Google Maps be important? Because it gives you an area of the vegetation. So you can actually kind of see where plant life already grows a little bit, you know. And so that's really kind of like, you know, we don't necessarily have a whole bunch of time to get into this stuff. So what I want for next week is I want you guys to think about where would be a good place to place a community garden in Chanute using those two links, okay? And then if you've got time, I would actually like you guys to check this out. We're gonna be, and this is actually a link to actually go to the Chrome store. And what it does is we're gonna be working with this game that's called Journey 2050. So we're gonna be working with this game called Journey 2050. It's available on Chrome. I've put my teacher code here. So my teacher code is FQMF. And so if you wanna try it, You can download the game, put in my teacher code, and then just do the introductory one. I think the first one's in Kenya, and it kind of just walks you through some of the concepts of how to grow a crop and what they're looking at. So don't worry about doing this third one. We won't do this. Looking to estimate the overall dimensions of a tree of your choice. We'll save that for next week, but I would like you guys to try to see if you can't find a place in Chanute using the heat maps and Google Maps to kind of like, where would you put a community garden in Chanute? And then what's really cool, guys, is that we can actually put something together and send it to the city commissioners and be like, hey, have you guys ever thought about actually putting in like a community garden? Because the last time, the community garden right now is kind of prone to flooding. So have you guys thought about putting a new community garden somewhere else in the town, you know, to help out with all kinds of stuff like that? So we can actually come up with a proposal and we can actually send it to the city commissioners. Now, whether or not they do anything with it, I don't know. But, you know, that's the first step, right? Is to do something fun like that. So I want to take the data from this class and I want to do something with it. And then, you know, if you get the chance.
Legacy.
Oh, go ahead. What?
Oh, I was just saying, this could be part of your legacy.
Yeah, it would be really cool. Upward bound, right? Start off, you guys. And then what would be really cool is if they actually did something about it and then you could go grow stuff there. That'd be pretty sweet too. So I'm not saying that I want a hot pepper farm, but I'm kind of saying I want a hot pepper farm. So anyway, oh, and my hot peppers are coming along fantastically well. Except I think somebody came by and picked my green pepper plant before I got them. I was kind of like, no, you guys suck. So anyway, and then you can download this game, this Journey 2050, and use my teacher code, and then you can try out that first introductory lesson. Okay. Yeah, right. Love growing peppers. I got ghost peppers, Scotch bonnets. I got crazy stuff. So, yeah, park. So take a look at those maps and come up with your proposals as where you guys want to put it. You guys can work together in groups on this too. You know, I don't care if you guys get together in your little study time and figure out like, I want to do this or I want to do that. And then just give this game a try, okay? So I'm going to grade your stuff. We got a due date today for your first assignment, so I'll take a look at what you did there. We had a discussion over a little bit about photosynthesis and about the color of wavelengths of light and LEDs. And then we can kind of get to this idea of, well, you know, that might be pretty costly. So can we do a community garden in the meantime? So I want you guys to take a look at that. That's what your assignments are for this upcoming week. Does anybody else have any questions or comments or anything like that? We good to go? All right, everybody. Hey, it's so great to see you. I like seeing everybody because all my students, they never like to do anything on the video. So it's nice to see some smiling faces. So I'm glad you're here and have a good weekend and I'll see you guys next week. Okay.